improve the user experience for cross-chain use cases, particularly for Bitcoin. Over the past few months, we worked with Reown and a talented group of developers to make this happen. My name is Oskar Pop, and I'm a software engineer at Bifrost Wallet. Bifrost is established as the official wallet in the Flare ecosystem. We currently support 11 different blockchains, and now we're expanding that support to include Bitcoin, Dogecoin, and Litecoin. In the last quarter, our focus has been on enhancing the cross-chain user experience. Specifically, we're working to enable the seamless bridging of Bitcoin to Flare through the F-asset system. This allows users to bring Bitcoin into a smart contract context where they can interact with dApps that require transaction signing on both Bitcoin and Flare. To make this happen, we need a wallet to dApp connection standard that supports both EVM and non-EVM chains. Without it, developers would need to integrate multiple standards, and users would have to switch between several wallets just to complete a single cross-chain flow. Our goal was to create a user experience where you can interact with one dApp, use one wallet, and sign the transactions on any blockchain, all without friction or unnecessary context switching. As mentioned earlier, the F-asset system allows non-smart contract tokens such as Bitcoin, Dogecoin, and XRP to be used trustlessly with smart contracts on Flare. More than 70% of total value of blockchain assets don't have smart contracts. This means that these assets are left out of the decentralized economy, unable to earn yield or participate in DeFi. But through the F-asset system, these non-smart contract tokens can be minted into F-assets, which allows them to be utilized in decentralized applications. And once they are on Flare, they can even be bridged to other networks, unlocking new use cases and possibilities. And later on, I'll show you what this minting process looks like in action. So there were a few existing standards for connecting wallets to Bitcoin dApps, but there was always a catch. Most only works with Bitcoin-specific dApps, not EVM-based ones. Or they forced wallets to reuse Bitcoin addresses, which compromises user privacy. For any standardization work, we believe it's important to work with existing parties and not propose yet another standard. Instead, we reached out to Xverse, Ledger Wallet, Asana, and Hero to get their perspectives. By collaborating with the key players, we came to the conclusion that Wallet Connect, which is developed by Reown, was the most established and flexible standard to support our use case. And for you that saw Ben from Reown's presentation earlier today, you will recognize some of the bits that I will present. So our biggest challenge was adapting Wallet Connect to fit Bitcoin's UTXO model. Wallet Connect was originally designed for account-based chains like Ethereum, where a user's address remains the same. But Bitcoin users, as many of you know, typically uses a new address for each transaction, which does not go hand in hand with the account-based standard. When we looked at existing standards, they were either account-based, allowing only the first Bitcoin address to be used, or they sent all addresses to the dApp. So our solution was to combine these approaches. We defined the first external address as the account address, so the user recognizes what account was connected, and we include any address with one or more UTXO, as well as a few unused ones, for the dApp to be able to propose transactions and calculate balances. So let's look at how this interaction works between the user, the wallet, and the dApp. The user connects to the DApp and sees their account address. After a few connections, the user should recognize the address since it remains consistent. And when the user connects, an address changed event is typically emitted, which gives the DApp the relevant addresses to be able to calculate the user's balance, for example. This event ensures that even as Bitcoin addresses change, the DApp stays in sync. The DApp uses the send transfer method to send a transfer request and can specify the amount, the recipient, change address, and a memo. The wallet takes care of selecting the UTXOs, minimizing user involvement. And if needed, the DApp can manually resync using the get account addresses method, ensuring it stays up to date with the wallet UTXOs and receive and change addresses. This event and two methods should be enough for most use cases, we think, but for more complex scenarios where the DApp needs full transaction control, we also support signed PSBT and signed message methods. And signed PSBT, for example, allows the DApp to send a partially signed Bitcoin transaction to the wallet for the user to sign and return. So I'm now going to show you a demo. It's a bit speed up, so I will try to keep up, but we will go to this F asset minting DApp. And then we press connect, and which allows us to connect for Wallet Connect. So on the connect model, we see different accounts we connect, and there is one per chain. And here we see the Bitcoin. We can also see here that we already have one pending mint transaction and that we have 0.0012 F BTC. We then press mint to begin the F asset mint process. We fill in the number of lots we want to mint, and then we start the minting process. We pay first the reservation fee in Flare. So on an EVM-based chain, the DApp then uses the send transfer method to propose the Bitcoin transaction. And in this case, amount, recipient, and a memo has been specified by the DApp, but we can change the network fee as we want. When the transaction has been submitted, the work of the user is done and the F asset system handles the rest. So in the first step, the Flare state connector waits for the transaction to be confirmed by 6 blocks. And in step 2, the state connector completes the proof of the payment. In step 3, the agent mints those F asset BTC. And in step 4, the tokens are sent to us, the user. And finally, we can see that our balance has increased to 0.002 F BTC. And finally, I just want to say that we look forward to continue collaborating with the Bitcoin community, working for improved interoperability and a better user experience. And if you have any questions, please feel free to reach out to us on X or our mail. Thank you.